Section 1.3, displaying quantitative data, dot plots. This is the first of a number of different graphical displays we'll go over for quantitative data. So in this data set here, we have the average miles per gallon for a number of different car models. We want to take this and create a dot plot. You've probably seen a dot plot before. You may or may not have had to make one. Step 1, draw and label the axes. And step 2, scale the axes. This is something that's pretty common as the first 2 steps of any graph that we make. So when we scale the axes, we would just want to make sure that we have enough room to fit all of our data on there. So when we look at this, we want to find the minimum and the maximum values, and then just choose a scale. Now, a lot of times, the first time people make a dot plot, they'll have every value, 25, 26, 27, 28, etc., all the way up to 48. We really don't need that. So I'm going to choose a smaller interval and just place the dots along that interval. So here we'll start at 25, and then we'll just go by 5s until we hit a number that can eventually fit that maximum. Step 3 is going to be to plot the values. Right now it's hard to make dots on my computer here, so I'm going to just do like squares instead. So we'll go through each one, and we'll make a little notation. So 30 would be here, 27 would be about here. Okay. And we go through them one at a time, okay, until we fill the whole thing. Now, some of the common mistakes is that when we have multiple things, like I see there's a 30 here, there's 2 more over here. All right, so when we start piling up our dots or squares in this case, all right, we want to make sure we stay even. So if we did, say, 31s, okay, we want to try to keep it at the same height. What I mean by that is if we did, say, 35, let's say there were 2 35s. We don't want to have one like this and the next one like a big block. Okay, so keep them where the second block stays relatively even. Okay, the third block again stays relatively even. All right, and this is what it would look like when it all comes together. Okay, if it wasn't clear what I was talking about, all right, anything that has 2 dots here is at that same height. Okay, these 5s are at that same height. All right, so explain what the dot above 38 means. It's referencing this dot right here. Okay, and that 38 is referring to the Honda Civic, which gets 38 miles per gallon. Okay, as always, we want to answer these questions in the context of the problem. What percentage of cars in the sample get more than 35 miles per gallon? We're just going to count up all the values that are more than 35. There's 3 of them, and we're going to make that into a percentage by putting it over the total number in our sample. So if we add up all these dots, we get 21. That's our sample size. We denote sample size with the variable n. Okay, so 3 over 21, 0.143, about 14.3% of cars in the sample get more than 35 miles per gallon. If we were asked to describe this distribution, okay, anytime we're describing a quantitative display, we're going to use the acronym SOX. And SOX stands for shape, outliers, center, and spread, which is just another way of talking about the variability or the variation in the graph. So let's go through all the different options for shape. Okay, and actually let me just put all of these up here. So we have roughly symmetric, okay, which is this one here. All right, anything that's unimodal and bell-shaped, we can describe as roughly symmetric. Skewed to the right is going to have a tail on the right. The right side is a bit larger than the left. Okay, we can see that in those arrows there. Skewed to the left is just the opposite. The left side is kind of drawn out. It's pulled towards the left there. That's where the tail is. The skew is always towards the tail. And to help remind you of which is which, think of it as a mountain. A skier going down it is going to ski towards the direction of the skew. 2 other shapes. Okay, these ones are a little more awkward. You won't see these ones as much. All right. This is approximately uniform. Okay, it should have the word approximately in front of it because it's not actually uniform. But uniform means that it's just staying around that same level. Okay, and this makes sense because it's talking about rolling a die 100 times. We're going to get about the same number of 1s, 2s, 3s, 4s, etc. The one on the right here is bimodal because there's two very distinct peaks. Okay, unimodal, like we would see in a bell-shaped curve, means there's one peak. Bimodal is two peaks, and then after that, we would just refer to it as multimodal. So that said, if we're asked to describe the distribution for this dot plot, we want to go through all four of those items in SOX. Now we've talked about shape. We're going to talk about how to find a center and a spread in the later sections. All right, so for now, we can just kind of eyeball it, what we think is the center, what we think is the spread. All right, and outliers, again, we can eyeball. So the distribution of highway gas mileage is skewed to the right. Okay, we have the peak here, and then it gets drawn out on the right side. With a center near 31, okay, I picked just in the middle there. A range of about 23. Okay, range is just one number. We don't want to say it ranges from 25 to 48. We want to say the range is 23. And a few high outliers between 38 and 48. I'm identifying all of these as outliers. If you chose to just say this one is an outlier, that's fine. For now, at least, eventually, we'll go over a way to determine mathematically if something is an outlier or not. So right now, we're just kind of going through SOX. Anything that we haven't learned, we're just taking our best guess at so we can hit all four components of SOX. Similar to the last section, we'll sometimes be asked to compare distributions. And when we're asked that question, we always want to note what's the same, what's different. And since it's a quantitative graph this time, we're going to use SOX. So before I actually answer this question, I'm just going to note the components of SOX for each of these. So the shape for both is skewed to the right. We can see it kind of trails off to the right there in both of these distributions. Outliers, there's a big gap here. Okay, so I'm going to identify that 125 as an outlier. And I don't see a similar sized gap at all in there in New Jersey. So I'm just going to say none. Okay, again, eventually we'll talk about how to mathematically determine if something is an outlier or not. Right now, we're just looking at it and taking our best guess. Center, okay, I'm just eyeballing the median. Median for Indiana is around 40. Okay, for New Jersey is around 50. Median is the halfway point. And then lastly, the spread. Right now, we're just going to use the range. And again, I'm eyeballing it. So Indiana, about 125. Okay, the scale we can see on the bottom here. It's the same scale for both graphs, which is always what we want when we're describing or comparing distributions, by the way. All right, and then New Jersey is from, a range of 160. Okay, range is always just one number. It's how far it's spanning. So putting that all into a little blurb, remember we always want our answers in the context of the problem, meaning about whatever the problem is about. The distribution of family incomes of Indiana and New Jersey are both skewed right. New Jersey's center and range are both higher than Indiana's. I reference what they are in parentheses. And then I note that Indiana has one high outlier around 125,000. New Jersey doesn't have any.